The Prime Minister of India visited the United States and signed a crucial contract, that is, the introduction of the F414 in 6 engine from GE Company of the United States. The contract requires the US company GE to provide India with a complete production line of F414, the first batch of 99 engines to provide power for the Indian Air Force's glorious Mk2. In addition to the transfer of production lines, the United States also provided a large number of core technologies with high technical gold content, including as many as 11 items such as key coating and processing of single crystal blades, special corrosion-resistant coatings, and powder metallurgy processing. Many countries have worked hard for decades to achieve technological breakthroughs, and India can easily obtain them. The materials used in aero engines are critical, so there are many related core technologies involved. From this point of view, India's aviation technology has achieved a great leap, and the future will usher in an era of explosion. But the reality may be the opposite. Many Indian experts even asserted that because of this deal, India's domestically made engines have officially ushered in the darkest moment. There will not be much development in the past 100 years by 2100, and there is no hope of using them in India. On the fighter plane. Then why is it even less optimistic about India's aviation technology after obtaining advanced technology? India's glorious fighter has multiple upgrade plans, but all use American-made engines. American Aerospace Development Corporation began to monopolize the Indian military aircraft market. American aviation development has monopolized the power market of India's glorious Mk1 and Mk1A fighter jets. 75 F404 engines have been delivered, and 99 units will be delivered in the future. GE can be regarded as making a lot of money. In the future, the Indian Air Force's advanced medium-sized stealth fighter AMCA will also directly use the American F414 engine. The company's products will continue to sell well for at least 20 years. The Indian Navy's twin-engine medium-sized carrier-based multi-purpose fighter also uses the same engine. Simply put, the Indian Air Force's self-developed fighter jet engines in the first 30 years and the next 20 years were all monopolized by GE. US aero engines are highly competitive products, and India's domestically produced engines are currently unable to fight back against this opponent. This is not the key. The most important thing is that the contract includes the transfer of 11 key technologies of high-performance aero engines to India. The list of these 11 key technologies currently includes special anti-erosion and corrosion coatings, turbine maintenance technology, compressor blisks and blades, coating and processing of single crystal turbine blades, processing and processing of hot end parts, coating, complete transfer of blisk processing technology, powder metallurgy processing technology, polymer matrix composite material technology, laser drilling technology for combustion chamber, long-axis boring technology. These technologies can be regarded as the bottom of the box of GE Company. It is the first time to transfer such sensitive technologies to the outside world. After obtaining these technologies, they can manufacture advanced aero engines. Therefore, they were strongly resisted by the US State Department, but they were finally sold to India. Similar technologies have been stuck in China and Russia. China tried to develop a medium thrust engine similar to the F404 in the early 1990s. After several attempts, there were no results. It took a long time to overcome the relevant technologies, and finally after 2010, the turbofan 13 engine was mass-produced. 2 more advanced domestically produced turbofan engines have also been tested. It took China 20 to 30 years to complete the process from imitation to self-development of the mid-propeller engine. The aviation technology that China used to be jealous of is now easily available in India, which is also very emotional. The key technology of jet engine includes manufacturing and processing of high-temperature resistant blisks and blades. Will ruin India's aviation industry for 100 years. For this contract, the Indian Air Force expressed great satisfaction. The F414 engine contract is firmly tied to the 3 domestically produced fighter jets in India, and the engine problem has now been completely resolved. The Indian military industry no longer considers being stuck in engine technology when developing the brilliant Mk2, AMCA, and TID fighter jets. It can concentrate on quickly promoting the development of aircraft and greatly reducing R&D costs. It can be said to be the core engine of the Indian Air Force and Navy in the future. India's domestic stealth fighter ACMA project. But some Indian media sang the opposite. They chanted the end of the dream of manufacturing in India. Until 2100, Indian fighter jets did not hope to use domestic engines. Airlines, surrendered to the American GE company. The media and experts believe that before the next century, India does not hope to use domestic engines. Of course, there is a little exaggeration. Some Indian experts also agree with this, and believe that under the state of GE's dominance of India's aviation industry, it is impossible for India to use domestic engines for a long time. DRDO and HAL have been questioned as betraying the country. The main reason is that India is too dependent on foreign advanced engines, which leads to almost no chance to try domestic engines. In the end, it only pursues the performance of the current aircraft and completely loses the opportunity for domestic products to be self-reliant. Another important reason is that the Indian aviation industry has been lagging behind for a long time and has many problems of its own. In particular, HAL has serious quality control and personnel training management problems. The quality of workers and technicians is seriously lacking in responsibility. The factory management is extensive, not resolved. Technology and production lines can be bought, but before India solves a large number of personnel quality and management problems, advanced production lines do not mean that advanced products can be produced. Not to mention the follow-up study of the technical principles, thoroughly digesting the technology, and realizing the technological leap of import imitation optimization self-developed next-generation products. India's domestic fighters did not give domestic engines a chance, and Indian military workers are not very up-to-date. The J-20 is also gradually replaced with the Chinese Heart. India voluntarily gives up major opportunities. India has been developing military engines since 1986, numbered GDX-35BS, named Kaveri, with a thrust-to-weight ratio of 8, a maximum afterburner thrust of just over 8 tons, and a maximum military thrust of 5 tons. After 33 years of hard work, it has encountered a lot of technical problems, including overweight, maximum afterburner thrust less than 1 ton, excessive vibration, surge, and other common serious engine problems. In fact, until here, the difficulties encountered in the development process of China Aviation Development Corporation are similar. But it is a pity that the Indian military industry did not persist, and the Indian Army did not give the opportunity to continue to try. In 2008, the project was completely cancelled, and more than 20 years of research and development fell short. India not only lost an engine project, but also missed a major opportunity for simultaneous trials on domestically made military aircraft, and there is little hope of turning around afterwards. Indian GDX-35BS engine model, the indicators are basically the same as the American F404 engine. China's aviation development road, India can't learn from it. Air India has lost a major opportunity, but its essence is still too eager for quick success and only cares about immediate interests. Buying off-the-shelf engines is naturally reliable and simple, but if you can't achieve independent research and development by buying them, you will always be able to use second-rate products that others don't want. However, the research and development of China aviation development and other military products rely on 2 legs. The state strongly supports the import of excellent technologies to solve the current problems, and finally achieve a thorough understanding of the technology before optimizing and upgrading, and even developing the next generation of products based on it. The Indian twin-engine carrier-based fighter jet project should not use Indian domestic engines anymore. It can be seen that China's path is very difficult, and walking on 2 lines at the same time means that it needs strong support from all levels of the country. It needs to dare to invest a lot of manpower, material resources, and financial resources. It requires experts and technicians to persist for decades. Research. But the return is undoubtedly the greatest, and the efficiency is also the highest. In just a few decades, China has become a country that has realized the national production of heavy fighters from a country known as a weak country in aviation development. In the future, stealth fighters equipped with turbofan 15 will form a strong national defense. Judging from India's current conditions, this difficult road should not be learned.